Hello, welcome back to the channel again. Let's discuss another problem. Problem number 236, lowest common ancestor of a binary tree. So we are given a binary tree and we need to find the lowest common ancestor of two given nodes in the tree. According to the definition on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in the tree that has both P and Q as descendants, and node can be a descendant of itself. So before we look at the example, let's look at the constraints. So P and Q, two given nodes, are not equal to each other, and we are guaranteed that P and Q will exist in the tree. And all node values are unique. And node values, they range from minus 10 power 9 to 10 power 9, and number of nodes in the tree is in the range from 2 to 10 power 5. So let's look at the example in the Blackboard. So we are given this tree and we need to find the P and Q lowest, we for the short notation we call LCA, P and Q is the lowest node in the tree that has both P and Q as descendants. So we have this root is located at 3. Now we need to find, let's say, what's the lowest common ancestor. Let's look at the example. So 5 and 1. So 5 is here, 1 is here. And one easy way to find is we need to construct path from the root to nodes. Let's say from 3 to 5. What's the path? From 3 to 5, there is only one edge, so 3 to 5. And from 3 to 1, there is another one, from 3 to 1. So what's the lowest node that they have in common, which is 3? And let's look at another example. So 6 and 7. 6 is located here, 7 is located here. So we need to construct the path 3, 5, and 6. So 3, 5, and 6. And up to 7, we can come to 5, then 2, then 7. 3, 5, 2, and 7. What's the lowest node that they have in common, which is 5. So 5 is the lowest common ancestor of 6 and 7, so we need to return 5. So another example, 5 and 4. So 5 is located here, 4 is located here, and we need to construct from 3, 5, so 3 and 5 to 4, 3, 5, 2, and 4. So 3, 5, 2, and 4. What's the lowest common ancestor? We can see it's 5. So we return 5. And one more example. So 9 and 10. So 3, 1, 8, and 10. So 3, 1, 8, and 10. And 2, it's a 9, and the 2, this is 10. So 3, 1, 8, and 9. So they have, what's a common ancestor? So they have 8, so we return 8. So we basically can construct this path into the list of the array, and we can iterate from the back of the array and return the first node that they have in common. Or we can do the recursion. Let's see how we can do with the recursion. So the first condition we need to check if the node is either P equal either to P or Q, the node is LCA itself. So what it means? So we can just iteratively look from root. We check if the root is equal to 5 and 2. If root is not equal to 5 or 2, then we just go check here. Then we see that 5 is returned first. So we found 5, so we return 5 from this side. Then after we return 5, we don't have to go to left or to right. Then we go to 2. and after we return any number from the left side, then we search from right side. From 1, then we go to the left, and is that equal to 2? No. Then we return null. And from the 8, we just search from the right side, then we return null or 0. Then this side is also null, then we return null. So the first side that that returned non-null element value is from the left side. So we return 5. Let's look at another example. So the first next condition is the first node returning both from right child and the left child is LCA. So what it means? Let's say we are given the 6 and 4. We recursively search for 6. We go to the left. Is 5 equal to 6? No. Then again left, and we see we found 6, so we return 6. Okay, then we go to the left, to the right. We search, is that 2 is equal to 4? No. Then we go to the left, and we don't return anything because it's then this doesn't have any child. That's the leaf node. Then we return null from the left side of the 2. Then we go to the right. After we go to the right, then we find 4, which is the node that we are searching for. So that we return 4, and 4 is returned to 5. And 5 is the node that returned both left child is coming 6, and from the right child coming 4. So then we return 5, 2, 3. 5 is the first node that has both left and right child. Then we iteratively, recursively go to the right side, the 1 and the 0, left side and the right side, they all return null. So after we return null, then we see the left side is returning null and the right side is returning 5. So the 5 is going to be LCA for 6 and 4. Let's look another one. Check if left returns none and return right. So let's say 0 and 8. 0 and 8 is located on left side, on the right side of the root. So we still go to the left side. We search 5, and it has it's not equal to any of the nodes. Then we go to the left. Then it returns null. Then we go to the right. Is that equal? No. Then we go to the left, and then it has, this is 7 is the leaf node. Then this returns nothing. So null. Then 4. This also returns null. Then this side returns null. So null from the left side, from null from the right side. So from 5 we return null. And we go to the right side, and we go to the 1. Is that equal? No. Then we go to the 0. Yes, we found. Then we return 0. Then we go to the right. Did you find 8? Yes, we found 8. Then we go to the, we return 8. So 1 is the first node that has left and the right child exists, right? They return. Then we return 1 back to the root. So we can see from the left side we are returning null, from the right side we are returning 1. So the 1 is going to be LCA for 0 and 8. So one more example. Let's say one more child is located 6, another child is located right here. So the same thing, we go to the left 5, and again left 6. So we return 6. From the right child of 5, we go to 2, then 7. It returns, let's say, null. Then we go to the 4, it returns null, right? Then 2 is null, from the left null, right null, it returns null. From the right side, left side we are returning 6 and null, so we return from here 6. No, I mean not 6. So we return 5, which has this node, and from right side we go to the right, then left, and we return 0. From here we return null, then 1 comes, right? So 1 comes back with left child non-zero. So 3 is the one that has both a left child and the right child. So basically 3 is LCA 4, 6, and 0. So let's look at the code. So let's write the code. So we are going to check if the root is none, or root is equal to p, or root is equal to q. In this case, we need to return root. Then we need to recursively go to the left side. We are going to copy this, and the same function, we are going recursively to the root dot left, and we search for p and q. And the same thing we do, we go to the right and we search recursively for the right side, the root dot right. Then we search for p and q. Now we are going to check if both left and right exist. We need to return root. Otherwise, we need to return left if left exists. Else we need to return right. So let's submit this problem. Yes, so it's accepted. So it's so we will also look at other variation where the node, we need to check if the node exists, or these nodes are given as a list, or some reference to the parent node in the different variations of this problem. So I'll see you guys in the next problems. Thank you.